Hi, good day, hello, and how are you? So, we're looking at a more in-depth idea about forces, motion, and so forth. So, in this series, we're going to look at momentum, forces, and how to draw forces diagram. Let's jump right in. We're going to look at what is the difference between mass and weight as one of the objective questions. Second objective question, describe how the resultant force can change the motion of a body. Objective question 3, calculate the resultant of two or more forces acting along the same line. And objective question number 4 is, what is the effect of friction, air resistance, or drag on a moving object? As you can see in this slide, I have some links to simulations to show us how it works when we have forces. So join me and we will go to this site. On this site, you can see various different simulations for forces and how they work. Let us jump into this one. Firstly, we will look at net force. Net force. So we need to put one person in, and we can put one person in. So, which force will be greater? The large person is adding a lot more force, right? But if we change this one to a smaller person who's closer, let's see what's happening. The motion is a lot slower than before. But let us return it and put two people on this side. They will be equal. But interestingly enough, when we move this person to here, it will still be equal, right? 100 and 100. And if we put this person here, it will still be both and still be both. But as soon as we add another person, we will cause an unbalanced force. So when the people were not able to move the cart, they were at balance. But as soon as we add one person, it means that we're creating imbalance. In the next one, we have motion. So here we apply a force. So when we apply a force to the right, and we go back to 0, it means the cart will continue going because we have no friction. So in this scene, we do not have any friction. So let's add someone here. Do you see how it slows down a little bit and then speeds up? Now we're going to apply a force in the opposite direction, but not a large force. So that means the object is still moving in the same direction, but we have slowed it down because we added the applied force. So as soon as we take the force away, what's happening? The object motion is slowing down. Well done. In the next simulation, we're adding friction. So we're adding friction because at the bottom here, you can see that it is not a flat and smooth surface anymore. So when we add some weight, we have to apply a lot more force to be able to move the objects. But when we stop applying the force, it will stop as well. And when we change the direction, what happens? We have to apply a large force as well. And as soon as we take the force away, the friction pulls it to a halt. What if we decrease the amount of weight? Because remember, weight is mass multiplied by acceleration downwards. We can add the force, and it's a lot easier to move the object of 50 kilograms than 150 kilograms, because in our calculations we can say that we have 150 kilograms in A. So A is what we don't have, force is what we applied, and we want to find the acceleration. So we have F divided by M. When you have F divided by M, F will be the force that you applied. Let's say we applied 120 newtons divided by the mass. The mass was 50 kilograms. This will give us a value of 2.4 meters per second squared. And if you don't know how to calculate forces or acceleration, please refer to one of the previous videos where we covered that. And we're back on the Find a Friend experiment page. Here, as you can see, I left a few links and you can jot them down so that you can find them yourself when you finish watching this video. So the first question that we need to think about after we've seen the simulation is, what changes during the simulation? We changed the weight because we added or took away mass. The second thing that changed was the force applied. And the third thing that changed was we added some friction. Second question, why is the forces arrow important? The forces arrow is important because it shows us the direction of the forces. If we just applied the force with the friction, we would not know which force was stronger than the other force. That's why it is very important that we know what direction the forces are going in. Third one, which things are controlled when the arrow grows? When the arrow grows, the thing that is controlled is either the force applied, which is growing, or the force of friction, which is growing when there is friction present. Fourth one, which things can be affected by applying a force? The motion, so acceleration and speed, will be affected when applying a force. So the larger the force, the faster the object can travel, or the more acceleration you give the object. That's it for this topic. I really hope you enjoyed it and that you have time to look into the different simulations that we did before. So that was that for this part of our motion and forces section. I really hope you enjoyed it and that you have time to go and look at the different links that I shared with you during this video. Enjoy your day.